All right, guys, here we go. I want to make sure that you guys are not robots. It's actually very easy, but you have to know how to plot polar points first, because this is all coming from. Remember that your r comma theta, that the radius is always in reference to the origin, right? Like the distance. Like so, if I tell you 3 comma pi over 6, that you're going to go to pi over 6, which is this one right here, the second line, and you're going to go 1, 2, 3, and you're going to put a point, and that this distance is 3. You guys know what I mean? Okay. This has more lines than the other ones, guys. That's because this one right here, the very first line, is pi over 12. And then the second one is 2 pi over 12, which is actually pi over 6. See? And then this one is 3 pi over 12, which is actually pi over 4. And then this one is 4 pi over 12, which is pi over 3. And then this one down here is 5 pi over 12. And this one, of course, is pi over 2. Haven't done anything crazy, right? Nothing crazy? All right, so check it out, guys. I know you have a calculator, but let's first see if we can derive some of these. See how that says negative 2 sine theta? So I'm going to write, I know that it's an r comma theta, but I'm going to put the theta first because those are the ones we're going to choose, and I'm going to put r like that. And I'm just going to choose thetas. I'm going to try to choose thetas that are pretty, like 0. That's the first one. If theta is 0, sine of 0 is 0, and 0 times negative 2 is 0. Does everyone see where I got 0, 0? I plugged in this theta in here, guys, into that equation. So I got 0, 0. Come on in. And I'm going to put a point at 0, 0. That's my first point. Point 1, point 1. Are we okay? Okay. I'm going to choose a point like pi over 6. Sine of pi over 6 is a half. Half of negative 2 is negative 1. So remember when you would plot the points, negative 1 comma pi over 6. So you go to pi over 6 first and then go negative 1. So I'm going to go to pi over 6 first. It's this line right here. This line right here. See that line? And I'm going to go negative 1. So I'm going to be in what quadrant? Quadrant 3. So I go, let me see. 1, 2, negative 1. Point right there. That's point 2. So that's point 2. I'm going to choose, what am I going to choose? Pi over 2. I guess we could choose, I already chose pi over 2. So I'm going to choose pi over 2. Sine of pi over 2 is 1. 1 times negative 2 is negative 2. See? So pi over 2, negative 2. 1, 2, point. 5 pi over 6. Job. I don't understand how you're choosing regular thetas. I'm choosing thetas that are pretty, guys, on purpose. Sine of 5 pi over 6 is a half. Negative 2 times half is negative 1. So that's going to be in quadrant 4. Do you guys see that? 5 pi over 6, and then move 2, so, oh, sorry, 1 point. 1, 2, 3, 4, and then if I keep going, so like pi, if I plug in a pi, sine of pi is 0, and I'm back at 0. See? And I'm back there. And that's my 5th point. Because, okay, I'll slow down, guys. Because this is polar, this is going to create nice, like a nice curve like this. There we go. What shape does that look like? I might have messed it up a little bit. A circle. A circle. So all of them, this is a circle. So all of them that look like this, a cosine theta or a sine theta, all these will be circles. And of course, as well as r equals some constant. Like 1, 2, 3. That's just a circle centered at the origin. So this is the only one that's centered at the origin. circle centered at origin with radius equal to whatever constant. What about this one? What about these two? If it's cosine, so let me go ahead and write the details here, guys. Notice this was sine, and I didn't do a good job of it, but I'm going to try to be more specific on the others. Notice this is sine. This is symmetric about the what axis? The y. So let me go ahead and put it here. So I'm going to say r equals a sine theta is symmetric about y-axis. All right, let's see. What else do we know? R equals a divided by 2. So what does that mean? That means that a is diameter. And then the center. So look at this, guys. Where's the center on this circle? Do that blue dot. So where is the center in Cartesian coordinates? The center is going to be, if it's a sine, so I'm going to write center. If a sine theta, if y equals a sine theta, comma, center is, parentheses, 0, comma, a divided by 2. Bless you. And I'll put the other one here. If y equals a cosine theta, comma, center is a over 2, comma, 0. How do we feel right now, guys? Okay, take out your calculator. We're going to practice just with these two right now. So let's reset it in case your calculator has a lot of junk in there. So how do we reset it? Second memory 712. All right, click on mode. This is going to be fun, guys. Click on where it says function, go to polar. And I'm going to click on y equals. And check it out. I'm just going to play with it. I'm going to write negative 2 sine theta. That's the graph we had right now. I'm going to push graph. And look at it. There it is. Child, that looks oval. That's not a circle. Okay, look. Let's make it look like a circle. Zoom number 5, square window. And then I'm going to zoom in. Zoom number 2 in. That's a circle. Cool, right? I want you to look. I just want you to see, guys, certain patterns. Look at the diameter of this circle is 2. Notice that the center of this circle is at 0, -1. That's at 2 divided by 2, remember? Look what happens if I go and I delete the negative. Delete. Look where it's going to be at now. Oh, wow. Isn't that cool? Yeah. I'm still symmetric on the y-axis. Look what happens. Look what happens, guys. I'm going to change the sine to a cosine. What do you think is going to happen? It's going to be on the x-axis now. Boop, look at that. The center is at 1, 0. Look what happens if I make this, 5. Check it out, guys. If I make this 5, the diameter is 5. Where's the center of the circle? 2.5. Look at this. I push graph. Oh, look. 1, 2, 2.5 is the center, and I know you can't see it, but let me change my window. Let me go to Xmax 6, and you'll be able to see it now. Boop. Chop, it looks like an oval. Okay, let's make a square window. 5. There it is. Cool, right? Look what happens when I make it negative. What do you think is going to happen? It's going to go to the other side. Graph. Look, see? Cool, right? So all of them that look like this, so look, here it is. You got it right there in your good notes. If it looks like a cosine theta or a sine theta, it's going to be a circle. If you have r equals 3, it's going to be centered at the origin with a radius of 3. Those are the easy ones. Cool? Okay, I'm going to jump to this one. Yeah, I already started, so I'm gonna start. Okay, I'm gonna go slow. I'm gonna try. I want you guys to notice when you had y equals -2 plus 5 sine theta or sine x. When you would graph, this is the midline, -2, and then I would go up 5 from -2, so 3. Here's -2, and then I would go down 5, so -7. -7. And let's see, this was sine, so 0, -2, so point, and I have a negative, so this would look like this. It's not perfect, guys, but I'm trying to more or less. Remember when we did that in the first semester? Okay. So here's what you should know about this. This graph, the biggest R that I'll have is 3, if you want to count the bigger number as the higher up. And the smallest the R will ever be is -7. And I know when you say magnitude, 7 is technically bigger than 3. So the biggest R will ever be is 3. The smallest will ever be is -7. Cool or not cool? Because R, you see, you see this that I'm putting in, let me change the color, purple. You see this that I'm putting in purple? R is changing signs. Because it's changing signs, that creates a loop. So I'm going to put that, let me put that in writing. If R changes signs, child, what does that mean? Positive to negative or negative to positive, comma. This creates loop. What are you talking about, loop? It's going to look like that with a loop. Child, why? Well, I'm going to try to do my best of my ability to try and graph. Notice it's sine theta, so it's going to be symmetric on the y-axis. Let's see. I'm going to say theta, and I'm going to say r. You guys ready? I'm going to go really slow. If theta is 0, sine of 0 is 0, I get -2. So let's plot that one first. 0 is the positive x-axis, -2. 1, 2, points. Next, what am I going to choose? I'm going to choose... I'm going to choose pi over 6, which I probably shouldn't, but I already said it. Sine of pi over 6 is a half. Half of 5 is 2.5. -2 minus 2.5, that's a -4.5. Check that I'm not making any mistakes. So I'm going to go to pi over 6, -4.5. So pi over 6, -4.5. So let's see, 1, 2, 3, 4, 4.5. Point. See? All right, next I'm going to choose pi over 2. Pi over 2 is 1. -2 minus 5 is -7. So I'm going to go to pi over 2, and then I'm going to go in reverse. -7. 1, 2, 3, 4, 5, 6, 7. Way over here. So there it is. My first point, my second point, my third point. That's your first. That's your second. There's my third. Let's see. My fourth, I'm going to choose. What am I going to choose? I'm going to choose 5 pi over 6. Sine of 5 pi over 6 is again half times 5 is 2.5. -2 minus 2.5, -4.5. So let's see, 5 pi over 6. It's the second one there. Boom, boom. 1, 2, 3, 4, 4.5. Point. Symmetric on the y-axis. I'm going to choose pi. So pi is, sine of pi is 0, so I'll just get -2. So pi is the negative x-axis, and then go backwards. 1, 2, reverse, reverse. Boom. All right, so this is my fourth. There's my fifth. And it is symmetric on the, let me keep going. Negative, 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 negative. Okay. I'm going to choose 7 pi over 6. 7 pi over 6 is a negative half. Negative half times -5 is a positive 2.5. -2 plus 2.5, that is 0.5. So you're going to be in quadrant 1, guys. 7 pi over 6 is quadrant 3, but then reverse. Actually, no. Did I mess up? Hold on, let me make sure. I think that happened last time. Sine of 7 pi over 6 is a negative half. Negative times a negative is a positive. Okay, we're in quadrant 3. So 7 pi over 6.5. So I'm going to stop right here because we're going to talk a little bit. 7.5, 7 pi over 6.5. 7 pi over 6.5. Boom, point. Okay, let me stop. Somewhere between here and here, somewhere between pi and 7 pi over 6, I switch signs. Do you guys see that? So that means, so let's see, what does that mean, Chop? That means, remember guys, the only way to switch signs, the only way to go from negative 2 to 0.5 is if r was 0. Do you guys agree? And if r is 0, that means I'm going right through the origin. So let me go ahead and say, label the 1, 2, 3. This is my 4th. This is my 5th. And this origin one is actually your 6th. And then that one will be your 7th. So I'm going to put 7th here. Chop, what are you saying? Okay, let me slow down, guys, because this can be tough. The only way that I can go from negative 2 to a positive 0.5 is that if r was 0 at some angle between pi and 7 pi over 6. Does that make sense? So if I start sketching this, it would look like this. And it kind of like a circular path, like that, and then like that, and then like that, and then like that, and then boom, boom. So like this.
Do you need to go like specific order?
Yes. You do need to go in specific order. Something like this, guys. Let me choose red. And then you're going to hit the 5th one. And then you're going to be, your R is getting smaller. So there it is. Remember, it's from reference to the origin. Your R is getting smaller. Then you're going to hit that. See, like that. Do you guys see what we did? Okay, Chow, where's the next one? I'm excited. I want to know where the next one is. Okay, let's choose 3 pi over 2. If I choose 3 pi over 2, sine of 3 pi over 2 is negative 1. Negative times a negative is a positive. So what's negative 2 plus 5? 3. So 3 pi over 2, 3. Put 3 pi over 2, 3. 1, 2, 3. Point. That's your eighth point. That's your eighth point. So there it is. It's going to go. See? And now watch. If I pick another one like 11 pi over 6. 11 pi over 6. 11 pi over 6. Look what's happening. Sine of 11 pi over 6 is negative half. Negative times a negative is a positive. So I'm going to have positive 2.5. Negative 2 plus 2.5 is 0.5. So my r is getting smaller and smaller as I get closer to 2 pi. Do you guys see that? So 11 pi over 6, 0.5. So it's going to look like this. Point right there. So, and then as I'm getting smaller, so look, I'm going to put 2 more points. I'm going to say the 9th. I'm going to say 2 pi. And then at 2 pi, it's going to be negative 2. Okay. Somewhere between the 11 pi over 6 and 2 pi, look how I went from 0.5 to negative 2. Do you guys see that? So somewhere between here and here, I had to have crossed the origin again. And then I'm going to call this point 11. So then that means, so what does that mean, Chop? So look, I'm going to call this point 11. And then so that means, so let me go with that. Let me write that. So 2 pi negative 2, I am over here again. So 0.11. And then I have to have hit this one again, 0.10. So that means I look something like this. This red one, look, it looks like this, guys. It goes through that one. That one was 0.9. That one was 0.9. I just didn't label it. And then 10. And then back to 11 like that. Boom. And there it is. Whew, that was tough. That was tough. Do you guys see what happened there? Okay. So from now on, for this to happen, the only way this is going to happen, look, it's right here. If R changes what? Signs. I have to go from negative to positive or positive to negative. So how do these graphs look? It has to be like this. It has to be like R equals A plus B sine theta. And I'll write the other one. R equals A plus B cosine theta. Don't worry, guys. I'm going to talk about this. This one is symmetric on the y-axis because of the sine. Symmetric on y-axis. And then notice this one. That one's symmetric on the y-axis, so that one's a sine. And then this one is symmetric on the what? On the x because of the cosine. Now, what did I say, guys? The a and b. So you have to. Let me see. Can we make a statement like b must be greater than a? Okay, it has to look like this: 3 plus 5 cosine theta, or it could also be 3 minus 5 cosine theta. See how I'm going to change signs there, or it could be 2 plus 4 sine theta, or 2 minus 4 sine theta. So I guess we can make a statement: as long as b is greater than a, you will get a loop. Does that make sense, guys? Why do you get a loop? Because R changes signs from positive to negative and negative to positive. Cool or not cool? Don't worry, we're going to show it right now with technology. We're going to show it right now. We're trying to. All right. Yes, ma'am. Yes, but relax. You'll probably have a curve, and you'll probably have to choose a multiple choice. I don't think I'll look at all the free response and see if they make you do it by hand. But if they do, it's probably like a little snippet. It's not the whole thing. So look at this one, guys. This one's going to have a loop because I am changing from positive to negative. So I'm going to go ahead and skip because we already did that. Look, see, this is similar. This is similar to the one that we just did. So I'm going to say similar to the one we just did. Similar to the one we just did. Okay, let's keep going. Ooh, look at this one. I love it. No, don't worry. We'll be fine. It's symmetric on the y-axis because it's a sine. Symmetric on y-axis. And I'm going to write theta, and I'm going to write r. I'm going to start at 0. So at 0, this is 0. So I'm going to put a point. Point. Okay. Let's see. I'm going to try really hard to see if I can figure out how to explain it clearly. This is a max. My max value is, so all my values for this is between negative 3 and 3, right? So sine 3 theta, 3 sine 3 theta. They're all going to be smaller than 3 and bigger than negative 3. They're all between negative 3 and 3, my R values. Because sine theta goes between negative 1 and 1, right? And I have a 3 in the front, so biggest is 3, smallest is negative 3. All right. If I plug in a power over 6, Chav, why did you just choose power over 6 randomly? I didn't. I'm trying to get this to be a power over 2. And I see a 3 in there. So if I plug in a power over 6, 3 goes into 6 twice. If I plug in a power over 6, I get 3. Do you guys see that? Put a point at power over 6, 3. It's this one right here. 1, 2, 3, point. That's the biggest. Okay, so let me see if I can explain this clearly. This is the biggest R is going to be. You know what? Let me do one more. I want to, because this is going to have 3 pedals. Boom, and then let me plug in, let's see, power over 6. Let's plug in power over 3. If I plug in power over 3, look at this, guys. Check it out. Bear with me. Don't worry. We're almost done. The 3's cancel out. What sign of pi? Okay. So look. Think about it. I need your A game, guys. I need your A game. Between 0 and power over 6, R is getting larger and larger and larger. This is the largest it'll ever be between this interval. See, right there. So between 0 and power over 6, so imagine you're doing a sweep. And remember, R. So this is probably going to look something like, and then boop, a peak right there. And then between power over 6 and power over 3, R is getting smaller. So from here, boop. Do you guys see that? So it's probably going to look something like, let's see, R is getting bigger. Boom, that's the biggest. And then right here's power over 3, right here, guys, this one. So as I get closer to power over 3, boom. Yeah, it's going to be a rose. That's what it's called. Oh my God. Do you guys see that? It's called a rose. Yeah. It's called a rose. If you keep going, it's going to be symmetric on the y-axis. It would look something like this. Let me see. 1, 2, 1, 2, 1, 1, 2, 3. Point. It will look something like 1, 2, 3. Point. Look something like that. If you were to keep going, right? Pi over 3, then pi over 2, 2 pi over 3. The max would be with magnitude of 3. So here, wherever you see. Oh, yeah. The over 6s. Yeah, on the other over 6, 5 pi over 6, you get another. And then add 3 pi over 2. Check it out. Take your calculator. Let's plug it in. Go to y equals. I'm going to plug in 3 cosine 3 theta. Push graph. Boop. Look at that. What happens if you change that theta to a 2? The coefficient in front of the theta to a 2. What do you think happens? Oh, look at that. How many petals do you see? 4. So here's the rule. Oh, by the way, look, I put a cosine and notice that it's, well, this one is symmetric on the x and y the way I put it in there. But if I put an odd one, if I put 3, if I put 5, look, I'm going to put 5. Boop. Child, why do they look kind of staggered? That's because my step sizes are too big. Don't try to make your step sizes too small, guys, because I have a computer here. So this computer is able to go pretty fast, but the calculator is not. Look, looks nice and pretty now. I made the step size really small so it can come out nice. So check it out, guys. I put, look what I put. I put a 5 in there and I have 5 petals. And it's symmetric on the cosine, on the x-axis. Symmetric on the x-axis. Look what happens. Don't worry, I see you, miss. Look what happens if I put 6. That's an even number. How many do you count? 12.
Okay, like so if it's odd, it's the exact number, but even is double.
There you go. That's what you're going to write. So here we go. So I'm going to say this is this one. That's called a rose. It's called a rose. And we're going to say your what? Okay. A cosine n theta or a sine n theta. What are we going to say? We're going to say an n is an integer. N is an integer, a positive integer. I guess we could also talk about negative integers, but we're not there yet. Or just say integer. If n is odd, comma, n petals. Petals, P-E-T-A-L-S. If n is even, how many petals? 2n. 2n petals. Is that making sense, guys? Okay. Now check it out. Let's go right to, so we already talked about the circle. We already talked about the rose. We already talked about the loop. Now we're going to talk about this one. It's called a cardioid. Sometimes called a butt or a heart. So let's see if we can find one. -4. Well, I guess that one technically is one of these. Okay. -2, that's just another circle. Another circle, I put it twice. -4 plus 2, that's one of these. Here it is. Go to -2 minus 2 cosine theta. Ask yourself this question. Does R ever change signs? Does R ever change signs? Does it ever go from negative to positive or vice versa? Now think about it. Look at it. The amplitude is -2. It will be 0, but it will never be positive. Do you guys see that? No? Okay. Yes, okay. Y equals -2 minus 2 cosine theta, or cosine x, like in the first semester. This is your midline, so here's my axis, and here is my midline, a -2. -2. And that's a cosine, -2 minus 2, -4, so it starts over here. So the smallest it'll ever be is -4. Let me see if I can change it. but the biggest it'll ever be is 0. And it starts at -4, it looks like, and it looks something like this. And I'm not drawing it perfect, but oh well, too bad. Will it ever cross the x-axis? So because it never crosses the x-axis, it will never have a loop. But it will, because it touches the 0, that's called a pole. Remember, when it hits that, that means R is 0. Because of that, it hits the origin. So this is going to create that. Do you guys see that?
Yeah.
All right, let's do some numbers. Theta and R. All right, here we go. 0. If I plug in a 0, cosine of 0 is 1. -2 minus -2 is 4. So -4. So 0, -4, 0, -4. I'm over here. 1, 2, 3, 4 points. Let's see. What am I going to plug in? It's cosine, so I'm going to plug in pi over 3. Child, why did you choose pi over 3? Because cosine of pi over 3 is a half. I'm putting perfect numbers. Cosine of pi over 3 is a half. Half of 2 is 1, but that's going to be -1. -2 minus 1 is -3. So I'm going to go to pi over 3, -3. So let me see. It's this one right here. And it's going to be 1, 2, -3. 1, 2, 3. Point. There it is. That's that point. So let me label them. This is number 1. This is number 2. I'm going to plug in pi over 2 now. Pi over 2. Cosine of pi over 2 is 0, so I'm just going to have -2. So pi over 2, -2, 1, 2. Remember, go to the angle first and then go reverse, the R. We still okay? That's my third one, so I'm going to put number 3. I'm going to go to 2 pi over 3. Child, why are you choosing 2 pi over 3? Because I'm choosing perfect numbers. Cosine of 2 pi over 3 is a -1/2. -1/2 times -2 is a +2. -2 plus 2 is 0. So at 2 pi over 3, so let me see, where's 2 pi over 3? Oh wait, hold on. Did I say 2? That's a mistake. It's not 0. It's not 0. Yeah, that was, how come you didn't fix me? Cosine of 2 pi over 3 is a -1/2. -1/2 times -2 is a +1. -2 plus 1 is a -1. Now we're right. Yeah, or else we would have had a messed up graph. 2 pi over 3, -1. So let's see. 2 pi over 3 is this guy, -1. So 2 pi over 3 is this guy, -1. Point right there. Oh. All right, that's my fourth point right there, guys. All right, here we go. Finally, I'm going to choose pi. Now we're going to get it. Yeah. Pi is -1. -1 times -2 is +2. -1 times -2 is +2. -2 plus 2 is 0. Yeah. Cool or not cool? Boom, right there.
Bro, where's the butt at?
Right there.
Bro, where?
Right there. Look, this is our first point. This is our second point. This is our third point. Fourth point. There's our fifth point. Let's keep going. I'm going to plug in 4 pi over 3. Yes. 4 pi over 3. If you plug in 4 pi over 3, you get a -1/2. -1/2 times -2 is a +1. -2 plus 1, -1. So go to 4 pi over 3, -1. So I'm going to be in quadrant 1, right? Yeah. Point. And what's the next point I'm going to choose? 3 pi over 2? 3 pi over 2 for 0? 3 pi over 2. If I choose 3 pi over 2, I get 0, I get -2. I get, -2. 3 pi over 2, -2, I'm up here. 1, 2, point. That's the 6th point. 4, 5, 6, 7. Oh, the 7th point. Yeah, that's a 4, 5, 6, 7. 4, 5, 6, 7. All right, one last one. I'm going to choose 5 pi over 3. Yes, 5 pi over 3. 5 pi over 3. Cosine of 5 pi over 3 is a half. Half of 2 is 1, but I'm going to have -1. -2 minus 1 is -3. So 5 pi over 3, -3. So go backwards. I'm in quadrant 2. Boom, boom. 1, 2, 3. Point. Okay, are you shocked that it looks symmetric about the x-axis? No. And by the way, if I were to go, let's do one more. So it can be full circle. 2 pi. 2 pi, cosine of 2 pi is 1. Negative 2 minus 2 is negative 4. So there it is, full circle. That's my ninth point. And my ninth point is back again right there. All right, let's follow the order, guys. Ready? Let's follow the order. I'm going to do it in red. This is my biggest one. Try and go like in a curve-like nature. Boom. 2, 3, 4, 5. Look, there's the butt. 6, 7. Or, cardioid. Yeah, it's a heart. Well, they call it a butt too. They call it both. Like, I've had professors. Yeah, go to YouTube and go watch some, and you'll see some of the people. No, just put graphing cardioids, and you'll hear like. Oh. All right, guys. Yeah, don't Google something bad. Like, yeah, okay. Maybe I should have just said it's a cardioid. Call it a cardioid. Call it a cardioid. All right. Some of these look, well, they are cardioids, but those don't have that indentation because it does not hit a pole. So you see this one right here, guys? I think we're ready. These right here do not, this one hits the pole like this one. So I'm going to put hits pole. When I say hits pole, it hits the origin. This one here does not hit pole. Does not hit pole. Child, why does it not hit pole? Because it never changes signs. R is never 0. Does that make sense? Okay, I think we might know enough. We know that's going to be a rose. Let me look at one that, you know what? Let's go ahead and do them all. General rule, you'll see that A and B are equal to each other at some point. You know what I mean? R equals A plus B sine theta, or R equals A plus B cosine theta. The magnitude of A will equal the magnitude of B. Or, I mean, how should we say it?
I think we just say
if A equals B. But it doesn't have to be A equals B. It could also be opposite signs. Because what if I have R equals negative 2 plus 2 cosine theta? Look, that's from the A and that's B. But this will still be, yeah, I think absolute value is probably best, right? If the absolute value of A equals absolute value of B, you will have a cardioid with that hits the pole. Cool? Oh, man. We got one left. Gonzaga, are we doing a better job today than yesterday?
Yeah, because I think the rules help a lot.
Okay. Let's go to this one. Check it out, guys. You see this one right here? Negative 4 minus 2 sine theta. There is nothing you can do. Is that one not in there?
Yeah. Oh,
there is nothing you can do to make this equal to 0. It will never equal 0. Why, Chav? Why will it never equal 0? Because look, guys, if you were to go y equals negative 4 minus 2 sine x, and you were to graph this graph, so let me draw a grid, and here's my x-axis. Here's negative 4 down here, and negative 4 plus 2, negative 2, here's the max, and here's negative 4 minus 2, here's the min. It would just look like this. Well, I might not draw it perfect here, but it would just look like that. Do you guys see how it never crosses the x-axis? So this graph is going to be like this one here. So let's see if we can draw it. This will be the last one. And then we'll go right into it and show you what's up. I'm going to go... I'm going to show you guys some deltas. We'll do it together. 0. If I plug in a 0, I get negative 4. So that's the first point I'm going to plug in. 0, negative 4. 1, 2, 3, 4. Point. If I plug in pi over 6, I get sine of pi over 6 is a half. Half of 2 is 1. 4 minus 1, negative 5. So pi over 6, negative 5. So pi over 6, 1, 2, and then negative 5 go in reverse. 1, 2, 3, 4, 5. Point. I'm going to plug in pi over 2. Sine of pi over 2 is 1. 4 minus 2 is negative 6. There it is. There's my max. Pi over 2, negative 6. So I'm going to be down here. 1, 2, 3, 4, 5, 6 point. If I plug in 5 pi over 6, sine of 5 pi over 6 is again half. 4 minus 1 is negative 5. So 5 pi over 6, negative 5. So I'm going to be in quadrant 4. So it's going to look like 1, 2, 3, 4, 5 point. Yeah, making sure it looks symmetric. I'm going to plug in pi. Sine of pi is 0, so negative 4. So pi negative 4, so I'm going to be 1, 2, 3, 4 point. Everything's looking good so far. I'm going to plug in 7 pi over 6. 7 pi over 6 is sine of that is a negative half. Negative times a negative is a positive, so it's going to be positive 1. Negative 4 plus 1 is negative 3. So 7 pi over 6, negative 3. 7 pi over 6, negative 3. 1, 2, 3 point. I'm going to plug in 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times negative 2 is positive 2. Negative 4 plus 2, negative 2. So 1, 2 point. So it's going to look something like this. Let's see if I have enough. So it's going to look something like it's not. I didn't drive very good, but I was trying to just be fast, and there it is. Nothing. It's not really all that exciting. Sometimes looks like it is still considered a cardioid, just doesn't have that. It doesn't hit a pole. So look, let's do some now. I think we've covered all of them, guys. Put in there for good notes that R does not change signs. See, you never cross the x-axis. R does not change signs. So if it doesn't change signs, you're gonna have one of those. And R is never equal to 0. And bless you, dot. R is never 0. So parentheses never hits pole. Never hits pole. Hitting the origin is your pole, guys. All right, so let's see. With no what's up? Ask me.
A is less than B?
Yes.
Is that Ava?
Yeah, that's Ava. That's Ava. I sent it to her earlier. Check it out, guys. We're done pretty much, I think. I'm going to do as many until you are happy. Polar graphing curves. Okay, you guys tell me. So check it out. Ready? Look at this. Negative 4 plus 3 cosine theta. Will this, notice that this is negative 4, and this 3, it doesn't reach. So will R always be the same sign? Yeah, it's always going to be negative. Do you guys see that? So it's going to be this one. It's a Limacon. That's the name. It's a Limacon with no inner loop. I click on it. All right. Now, Chav, how do I decide? Okay, think about it, guys. When cosine is 0, negative 4 plus 3 is 1, right? So at 0, I should be at 1. So we'll let that take care of itself. Let's go ahead and do the maximum. When cosine is pi, cosine of pi is negative 1, negative 4 minus 3, 4, 5, 6, 7. So at pi, negative 7. So that means here's pi, the y-axis, but negative 7, I go in reverse. So 1, 2, 3, 4, 5, 6, 7. There it is. And I think I got the other one. See, because at 0 is negative 1. So here's the 0, bless you. Here's the 0 axis, negative 1, poop. There it is. It took care of it. And look, symmetric on the x-axis. Submit. Boom. And look, here's what I wanted to show you guys. Check it out. Here's what we were trying to do, but it's way easier with technology. Look, as I move this curve here, look at the right, look at the sinusoidal curve, and look what's happening to the left. See? Boom. See, I'll never cross the x-axis, so it never creates a loop. Cool, right? Yeah, no, don't worry. Look, it's gonna be super cool as soon as. Let me find one. -3 plus 2. No, let me find. Let me find. That's just a circle. That's just a line. A line. -3. Here, perfect. Look at this. This one will change signs. Do you guys see that? Because look, that's 3, but that's -5. So you will cross the x-axis. So this one's going to create an inner loop. It's a limacon with a loop. So I click on this one. And then let's see. If I have 0, if I put 0 in there, 3 minus 5 is -2. So 0, -2. So I'm going to put this little guy, 0, -2. And I think the other one, let me see if I did it right. Cosine 0, -2, yeah. And if I plug in pi will take that -1, so it'll become 5 plus 3, 5, 6, 7, 8. So at pi, you're at 8. Does that make sense? Look at this, guys. I'm going to go to pi, and I'm going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8. Look at that. Yeah, don't worry about what's going on outside. So there it is. Look how awesome that was. Now check it out. If I get it wrong, we'll get tacos for everyone. But it's correct. Here's what I want you guys to see. Look, yeah. Guys, look, check it out. I want you to notice what happens when you cross the x-axis on the right-hand side. Oh, sorry, I'm not trying to yell. I'm sorry, I don't want to share anymore. Okay, look at this. Pay attention to this and look at that. I'm going to go real slow. Look at this, guys. Look how awesome this is. This is why I love Delta sometimes, because of this. Look what happens when boom. That crossing it creates a loop. Crossing it creates a loop. And look what happens when I cross it again. When I cross it, it's going to finish that loop. Look, here it is at 0, and then look, boom, creates that little loop. Do you guys see that? So when you cross, yeah, boom, that turns 2, boom, boom. Okay, anyways, so wasn't that cool, guys?
Yeah.
So now you know when you cross the x-axis, when R is changing signs, that's what creates that little loop. So there it is, guys. I think. Do you feel comfortable with this now?
Yeah.
Look, 4 plus 2, 4 minus 2. This will never cross the x-axis. So there's going to be a limacon with no inner loop. Do you guys see? Theta equals pi over 6. That's just a line, guys, at pi over 6. It's always, you just go, where's pi over 6? It's the second one. And it's just, so that one's not even no biggie. If you put a little thought into it, everyone will get it right. Because it's just logic. Math is supposed to be the easiest class. 3 plus 5 sine theta, that's going to be a loop. Because R is going to be changing signs. Do you guys see that? So you just put, it's going to create a loop. But I don't know how to, guys, you just got to put a little bit of thought. Not a lot, just a little bit. So you go, okay, well, let's see. What makes this a 1? Sine theta a 1 if theta is pi over 2. Pi over 2, so sine of pi over 2 is 1. 5 plus 3 is 8. And pi over 2, 8. So it's probably this big one here. So you take this guy right here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, how to do the little one, Chav? Okay, well, what makes this one a negative? 3 pi over 2. Sine of 3 pi over 2 is negative. So -5 plus 3, that's -2. So, but remember, we said 3 pi over 2, right? 3 pi over 2, but -2 goes up. So I take the little guy here, and I'm going to go up another one more. Boop. Submit. See? Look at that. Like, oh, yeah. Oh, okay, yeah. Yeah. Cool or not cool? Do you think we've done enough?
I mean, I think you're just getting used to the rules.
Yeah. And there's obvious patterns. Once you've done 2 or 3 with the patterns, like, oh, okay, it's not so bad. Like, there's obvious patterns to this. Does that make sense, guys? All right, guys.
Rose?
Should we do what?
Another rose?
Yeah. You know what? Let's do one here that creates a rose. Let's just do 1 and 2. Look, we got a rose here. You see how it says 2 theta in there? How many petals am I going to have?
2.
No.
4.
4. I'm going to click rose, and I'm going to put 4. And now check it out. All you got to do, see, it creates 4 petals. But Chav, I have no idea how it's going to look. It's a sine graph, so it's symmetric on the y-axis. Well, it doesn't matter because it's 4 petals. It's symmetric on y and x. But the maximum magnitude, you got to think, where will I get this 2 theta to be pi over 2? Well, if I have pi over 4. If theta is pi over 4. Right? If in case you don't understand, guys, you can always do this. Because remember, we want this to be a maximum. You could always do this. Can everyone see from over there? You could always say, what is it? 2 theta. You can always say, I want 2 theta to be pi over 2. Divide by 2, divide by 2. Oh, theta has to be power 4. So that's where I have my maximum. That's where my maximum happens. All you got to do is get one of the pedals, guys. So look, check it out. Check it out. I'm going to grab one of the pedals. You see that one with the dots? I'm going to grab that one, and I'm going to go to power 4, and I'm going to go to my max value of 5. So I'm going to go to power 4. What, Chop, I don't know which one's the power 4. It's this one right here, the one in the middle. There's 1, 2, 3, 4, 5, 6, I guess. Well, the one in the middle is the power 4. So here it is, the one in the middle right there. And I count 1, 2, 3, 4. And there it is. That's it. So, 5. I would have gotten it wrong. 5. No.
Sorry,
Because no, that was just for that one. That was just for that one. And there it is, guys. Does that make sense of how we did it? Look at that, man. That is just awesome. Look at that. Yeah, it's so cool, right? Make sure that you mess around with this, guys, so you guys can see what's happening, the dynamics of it. Do you have to be an expert? No. Know what's happening, the interactions. We're not asking for you to be perfect, just for you to kind of more or less like understand how everything's related. Does that make sense? We're not asking for perfection, guys. Cool or not cool? Okay, I'm glad. I hope you enjoyed today's activity. Thank you for choosing room 206. We know you have many options and many choices. Let's get at it, guys.
I had no option. I don't know the colors.